Now let's look at the next example problem, 2-city scheduling from LeetCode. So a company wants to interview 2 people, and they will fly them into 2 cities. So each person goes to one of the 2 cities, city A and city B. In fact, we want exactly n people to go to city A and n people to go to city B. And for each person, there are 2 costs. So the cost of flying the person to city A and the cost of flying the person to city B. So we want to figure out what's the minimum cost so that every person will go to one of the 2 cities, and exactly n people are in each city. So let's look at the example. We have 4 people. And these are their costs going to city A, city B. So staring at this enough, I believe you can figure out the optimal solution would be 230, where the first and the second will go to city A, so that's 110, and third and fourth will go to city B, 120, so that's 230. So look at this. It might appear that for the third person, we really want the third person to go to city A because then we'll be paying less. However, no matter which person we switch out, we will going to pay more. So this is the optimal solution. So I want you to think about how many ways of partitioning exist. So in other words, if we do an exhaustive search, what will be the cost, the computational cost? And if we don't want to consider all the possibilities, then what heuristic to use for us to figure out to find out the optimal way of allocating the 2n people to the 2 cities? So we have 2n people, and we are choosing n of them to go to city A. So the number of ways is 2n chooses n, which is 2n factorial divided by n factorial, which is quite a bit bigger than 2 to the n. So I won't explain why. And for heuristics, we can try a few things. One of them is if for each person we choose whichever city that's cheaper. So in some sense, that makes logical sense, right? Because that will give us the lowest cost. The problem is that we cannot guarantee an even split. So for example, in this case, we will prefer the first person go to city A, but we can only have two persons go to city A. So then I guess one might try another heuristic is for city A, we just pick the one that's lowest cost. So in that case, we'll actually pick person 1 and person 3. But obviously that doesn't work because even for person 4, it's better to go to city B. So finally, one way to view this problem is, suppose we start by having everyone in city B. We have 2n person in city B. So then we need to pick n of them to go to city A. And each one we pick, we will save some money, right? So because of course the amount of save could be negative. So for example, when we pick the first one, we'll save 90. Second one we save 100. This one we save 60. This one we save negative 10. So obviously we want to choose the ones where we save the most. So in that case, we'll pick the first 2. So that heuristic would be correct. And we can prove this a little bit more formally, even though I think intuition is sufficient for this particular problem. So again, starting from the state where all 2n people are in B, then yeah, I think it's pretty obvious. We want to pick the people whose saving amount is the most, or the cost of A minus cost of B. So this is a negative saving amount. Is high. So I guess this really shouldn't be called saving. This would be kind of additional cost is the lowest. But essentially, yeah, we want to pick that. So we can make it a little bit more formal using exchange argument by exchange the two person, and we will get a better state if we didn't choose the ones where this a minus b is the smallest n such persons. So this is my Java code. So I want you to pay a little bit attention to the way this code is implemented, because it only sorts the original arrays. It doesn't create any new array to be sorted, but it's not sorted based on either cost A or cost B. Instead, it's sorted based on the cost to go to CTA minus cost to go to CTB. So I use a custom comparator to do that. And this is generally will simplify code when you need to sort things based on some complicated logic instead of creating that array corresponding to it. So I could have created a new 2D array where the first element, I have a 1D array for each city, and the first element could be this A0 minus A1, and the second could be the index into the cost array. And I guess if I'm not allowed to change the cost array, that's probably what I would do. But even in that case, I can use a custom comparator by sorting a 1D array, just index into this cost. Basically, sorting the city of a person IDs, and I use a custom comparator to use this to sort instead of other criteria. So after I sort it, it's pretty straightforward. The first n person goes to CTA, and then the last n person go to CTB.